this time. Alright, so let's go through and we'll name these monatomic ions. So N negative 3,
Nitride.
nitride. Right? If you have ferric, first of all, what are the two charges for iron?
2 and 3.
2 and 3. If it's ic, it's higher or lower?
Higher.
Higher. So which one is this one?
Iron 3.
Iron 3. Or Fe,
3.
positive 3. Make sure that when you're doing this, you put the plus and minus, so don't just put a number down. Okay, Pb positive 2, what are the two charges for lead?
2 and 4.
2 and 4. Okay, so this is lower than two charges, so this is lead 2, or
It's,
these we call plumbum, so this is
Columbus.
plumbus. Good. Alright, what are the two charges for manganese?
It's 2.
2 and 3.
2 and 3. Ic is which one?
Higher.
Higher charge.
So it's 3.
So it's
Manganese
manganese 3.
This is manganese 3, Mn positive 3. Oxide?
Oxygen.
O negative.
Now, you can pull out periodic table, you can use a periodic table in front of you.
Oxygen negative 2. O negative
It's
2.
negative
To
2.
group 16, which has a negative 2 charge. So from here on out, you'll have a periodic table in front of you.
Gotta challenge
Okay, I wish I
myself.
could put a periodic table on the table here.
I
so
gotta
that-
challenge myself.
Yeah, that'd be cool.
No periodic table. Gotta challenge myself.
Right? H negative 1 is called
That's hydride.
hydride. Good. Alright, two charges for manganese is what? 2 and 3. This is the lower one, so this is
Manganese.
manganese or
Manganese 2.
manganese 2. F negative 1.
Fluoride.
Good. Two charges for chromium.
2 and 3.
2 and 3. This is lower two charges, so this is
Chromus.
chromis. Just chromium 2. Gold negative 2.
Oxide.
Oxide. CO positive 2. What two charges for cobalt?
2 and 3.
Cobaltus.
2 and Cobaltus.
Cobaltus. This is lower the two charges, so cobalt 2, cobaltus. I negative 1.
Iodide.
Okay, S negative 2.
Sulfide.
Sulfide. Phosphide. Group 15.
E negative 4.
3.
Negative 3. Remember, 0, negative 1, negative 2, negative 3. It's in that negative 3 column. Cl negative 1.
Fluoride.
Fluoride. Fluoride.
F negative 1.
Group 17, so it's a negative 1 charge. What are the two charges for mercury?
2 and 2. 1 and 2. 1 and 2.
1 and 2. This is IC, this is higher or lower charge?
Higher. Mercury 2.
This is
Mercury.
So, what's the formula for it?
For what?
What's the formula?
HD2.
Okay. Hg positive 2.
I'm done.
What are the two charges for chromium?
2 and 3.
2 and 3. This is the higher of the charges, so this is
Chromic.
chromium 3. Alright, two charges for manganese.
2 and 3.
2 and 3. This is the higher one, so this is
Manganic.
manganic, or manganese 2. I'm sorry. Let's get manganese 3. What are the two charges for iron?
2 and 3.
2 and 3.
Iron.
OUS is which one?
Lower 1.
Iron positive.
Iron 2. Iron
Fe
positive 2.
Actually, Fe positive 2.
Fe positive 2, iron 2. Br negative 1 is called
Bromide.
chromic. What are the two charges for chromium?
2 and 3.
2 and 3. So which one is this one?
CR positive 3.
Cr positive 3. Also called chromium 3. Good. Just keep in mind here that whatever you see here is the same thing that's going to be down here. Okay? With the exception of that one mercury one. That's the only one that's going to be an exception to that. Hg2 positive 2. What are the two charges for mercury?
One and two.
It's just mercury.
Mercury.
Which one is this one?
One.
This is mercury one, this is that weird one. Mercury one or mercurous. Sounds weird,
Mm-hmm. Mercury.
sounds like Roca. Okay, 2 charges for copper,
1 and 2.
Or
Or
one and-
4. 1 and 2, yeah.
1 and 2. In fact, this, all of them have a 2, and this is positive 1,
This is Cuprous.
okay? So this is copper 1, or what was the other one?
Cuprous.
Cuprous. 2 charges for cobalt,
2 and 3.
2 and 3, so which one is this one?
CO2.
3.
IC is higher than the 2 charges. Cobalt 3, cobalt, or CO positive 3. Sulfide,
That's negative 2.
that's negative 2. 2 charges for 10,
1 and 4. Or 2 and 4 I meant.
2 and 4. This is, it's a 4, so which one is this one?
This is, this one has a weird name, doesn't it?
10 used to be called stanum.
Stanley.
So this is stannic. 10-4 or stannic. Bromide,
Oh, that's, BR negative 1.
group 17, BR negative 1. 2 charges for copper,
1 and 2.
Cupric.
1 and 2. So this is the higher than 2
Cuprous.
charges.
Cupric.
Which one?
Cupric.
Yelling at it.
Cooper.
Yep.
Cu positive 2 and Cooper.
You're yelling.
What's key negative 3?
Phosphide.
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 2 charges for 10,
2 and 4.
2 and 4. So which one is this one?
4.
S
Higher 1. So, and 4, less than positive 4. 2 charges for iron, 2 and 3. This is the lower one, so this is
Iron 2 or ferrous.
ferrous. Ferric. Yeah, I'm sorry.
Ferrous, sweet.
Yeah. It's been a long day. Alright, 2 charges for copper, 1 and 2. So, ick is which one? 2. Is copper 2, Cu positive 2. Hg positive 2, what are the 2 charges for mercury?
1 and 2.
1 and 2. So which one is this one?
2.
Okay, this is mercury 2 or mercur,
Or mercury.
mercuric,
Right.
alright? 2 charges for copper,
1 and 2.
1 and 2, which one is this one?
Lower one.
Lower 1, Cu positive 1. 2 charges for cobalt, 2 and 3, which one is this one?
CO2.
2.
2. CO positive 2. 2 charges for lead,
1 or 2. Or 2 and 4.
2 and 4, which one is this one?
2.
2. So this is lead,
2. Positive 2.
lead 2, UV positive 2. 2 charges for chromium, 2 and 3, which one is this one?
2.
2. So this is chromium 2, Cr positive 2. 2 charges for 10,
Oh, 2 and 4.
2 and 4. So this one is called 10,
Oh, this is, it's,
Stannis.
this is stannous, okay, or 10-2. Carbide,
Negative 4.
Negative 4. Carbon negative
14, C negative
C
4.
negative 4.
Mercurous, what 2 charges for mercury?
This is
1
Hg
1 and 2.
2. Positive 2.
Which one is this one?
The Hg subscript 2 positive 2.
Right. So this is mercury 1, or Ag2 positive 2. This is the really weird one. 2 charges for lead,
2 and 4.
4, so this is a higher of the 2, so
Plumbic.
this is plumbic, or lead 4. 2 charges for manganese,
2 and 3.
2 and 3, so which one is this one?
And then positive 2.
these two. Two charges for iron,
2 and 3.
so this is a higher one,
Ferric.
here, or iron 3. Two charges for cobalt, 2 and 3. This is a higher one, so this is
Cobaltic.
cobalt 3. Plumbic, 2 charges for lead, 2 and 4. So which one is this one?
This is
4.
PB4.
And this is positive 4 one. Nitride.
Or that's -3.
And
Yeah,
negative.
two group 15, so that's a -3 charge. C -4,
Carbon.
carbon. Was it?
Carbide.
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 2 charges for 10, 2 and 4. Which one is this one?
2.
Yep. Okay. I said positive 2. Alright? How do you feel with these?
Fine.
Good? You guys wanna ace it?
Yep.
Mhm.
That's what I like to hear. Alright, so, keep your eye, or keep your form of, periodic tables out. Get your ion papers and also get your, papers when we're looking at different examples.
Like that paper.
Yeah. Let's get around here. So, there's an earthquake. Okay. I don't know why this thing is kind of put to the side here, but try some here. That might work better. Okay. All right, a little bit of practice, a little bit of review here. Which ones have we done so far?
Aluminum and
Aluminum.
calcium.
And calcium chloride, okay. Alright, did we do one with iron? Was it? No? Okay. So, let's try this one here. If you have Fe positive 3 and O negative 2. Now remember, whenever you're writing these out, you always write the positive ions first. Okay? And same thing whenever you're naming these are always gonna be, you always name the positive ion first. Now, a molecule needs to be electrically neutral. Right now, we have a positive 1 overall. You cannot change the charges. But you can change how many of each one you usually have. So, what number can both of these go into? 6. So I need a positive 6 and a negative 6. So I need another iron and more oxygens here. So I have Fe positive 3, O negative 2. What do I put after iron? The subscript 2 down here.
Subscript 3.
And then subscript 3 after the oxygen. Now, just kind of double check your charges. 2 times positive 3 gives me what? Positive 6. 3 times negative 2 is negative 6. So positive 6, negative 6, the whole thing equals 0. For the name of this, what would it be?
Ferric oxide.
Okay. So this is called ferric oxide. I rename the positive ion and then negative ion. The number, the fact you have subscripts down here does not matter. What's the other name for it?
Iron 2 oxide. Or iron 3, sorry.
Iron 3 oxide, goes by the charge. So parentheses, Roman numeral 3, close parentheses, oxide. So ferric oxide or iron 3 oxide are both the same thing. Now, let's try another one. That's similar to that one. If I have Fe positive 2, O negative 2.
It's good.
What did I do to bounce it?
You don't have to do anything.
It's already bounced. So, now, excuse me.
choked up over this stuff. What would you call this?
Ferrous
Ferrous
oxide.
oxide.
This is ferrous oxide.
Iron 2 oxide.
Or iron 2 oxide. So both of these are actually a form of rust. The difference here is that this is more the reddish rust. This is more a bit more of a darker, kind of a blackish rust. You ever see something like a piece of sheet metal that's rusting here? You see like little red spots. You see some black spots here. That's those two different oxides. And what you cannot do is you cannot say, oh, this is iron oxide. Well, the problem is, so is this. Technically, this is also iron oxide. But chemically speaking, they're completely different types of compounds. All right, let's try another one here. If I have magnesium, what charge is magnesium? Positive 2. It's a group 2, so that's positive 2. If I combine it also with oxygen, what charge is oxygen? You got 2, it's a group 16. What do I have to do to balance it? Nothing, it's already balanced again. What's the name for this?
Manganese oxide.
Magnesium.
Oh, it's magnesium?
Magnesium. So, it's just magnesium.
Oh, yeah, it's a magnesium ion.
Magnesium ion and then oxide ion. You drop the word ion from both names. So it becomes magnesium oxide. Now, let me show you what that looks like. Now, I've shown to you before what magnesium looks like. And this is the one where I put it into water and it's kind of sort of bubbles very slowly. Okay, and if you look at it, a typical gray silver, kind of shiny. It would be a lot shinier if I sanded it just a little bit. Okay, it also tends to be pretty malleable. Show the see. Okay, now I'm gonna spin this around over here. Right about there. Would do. Okay. What I'm gonna do is this set tongs. That's not good. Okay, I'm gonna get a better set of tongs.
That's sweet.
Okay. Now, Espen, can you get the lights, sir? So right now, this is just a piece of magnesium, and make sure it'll be somewhat centered in the frame there. Yep. Okay. And when I light this, you can go ahead and have a seat here. When I light this, don't look directly at it. Okay. You can look off to the side, but don't stare directly at it. Otherwise, you're going to be seeing this great big blind spotted in your eyes here. The other thing is too, take a moment and kind of look around the room. You might see some, like the shadows on the walls would be pretty intense. Okay. Is it anyone's birthday today? No? Okay, I was going to say happy birthday while we light
It was
this.
CJ's.
What's that?
Oh
Yesterday
wait,
was
that was
CJ.
yesterday.
It was Hunter's.
Yeah,
Oh, yeah,
it was
it is
Hunter's.
No, this is not in here, so hang on. Now, this is, if you ever played with the sparklers during 4th of July, okay, that's kind of what's on the outside of this. Or if you ever watch the fireworks and kind of the white sparkly ones coming down, that's magnesium that's reacting. And in the process, it's making magnesium oxide. This is also sometimes put onto welding rods. And if you're familiar with welding rods, you gotta wear some protective gears and, eye goggles here because of the light is very intense. Basically, that's what we're doing here, okay? So, let me, like this, I'm gonna look at the differences between them. If you remember, it's kind of a gray, silvery color. There we go. Happy birthday to you.
Holy.
See the shadows on the, look at the shadows on the ceiling there.
Oh my god.
Look, they're doggy.
That's way brighter than I thought it'd be.
Yeah.
Holy.
See the spots?
No, like when you weld so bright.
Yeah.
That was way brighter than I thought it'd be.
I told you.
Yeah. I figured since
There
I
you go.
said it'd be bright, it was probably.
Alright, I'm sorry, can you get the lights? So a couple things to notice here
Oh my god.
is, first of all, if you look at my tongs, they are coated in white. And then also, where's my hand at? Come on now, there you go. The magnesium is now all white. Doesn't have the typical shiny metallic color to it anymore. But this is now magnesium oxide.
That's cool. That's cool. It smells weird.
That might be something to finish off on the tongs here. The other thing is, if you look at the, where is it at here? Okay, you take this, and it's kind of a chalky type of material. Okay, and hold out your hand. I'll give you a little piece here. Just don't rub it on other people here.
Oh, perfect. Oh,
Break it.
Okay, just take it and see how this falls apart.
it's like field chalk.
Yeah, that's what it feels like.
It's like grass on field.
And if you have, for lifting or something like that, or if you ever see like gymnastics, they use that chalk thing here. That's what, to me, it kind of feels like a little bit like cornstarch. If you ever played around with
Yeah.
cornstarch before? That powdered cornstarch. So, but that is the magnesium oxide. Now, from looking at that, what do you think happened to the weight of it?
It got a lot lighter.
You got lighter?
Maybe.
This had a certain amount, right? When it was done, it was still a solid, right?
It got heavier.
Got heavier.
Oh.
It actually will get heavier. Because now, not only do we have the weight of magnesium, but also we have the weight of the oxygen attached to it.
Like noticeably heavier?
Yeah, it's measurable. Fingers crossed here, hopefully we're still in school and everything like that. Later on, when we start getting into, it's an area called stoichiometry, and we're looking for percent yield. And this is a common lab that we have to do, where you'll be measuring that. If you take a piece of, same thing is true with iron when it rusts. Rust weighs more than the original metal that was originally. In other words, if you take a nail and, fresh, brand new nail, weigh it, and then let it sit and get rusty and everything else like that, as long as you don't break out pieces or anything like that, the rusted nail will weigh more than the original iron nail from the very beginning of it. Now, it falls apart easier, but it weighs more than it was originally. Okay? You guys pretty comfortable with this? Okay. So, I have an activity, a worksheet for you guys to do here. Looks like this. Okay. And some of you might even get this done before the end of the period. If not, homework here. First thing I want you to do is, before you get started on it, is I want you to write the name of the ions, and that's written up here.
can see there or not, it's a little bit of glare.
So, across the top of the paper, you have your positive ions. So, so right above Na positive 1, write down sodium ion. Mg positive 2, right up here, put down magnesium ion. You have aluminum ion, and then Sn positive 4 has two names, write down both names. It's called 10-4, remember the Roman number 4 in parentheses, and also it's called a stannic ion. So write those names down. Then along the left-hand side, you have the chloride, oxide, phosphide, carbide, sulfide. Write those names down here as well. So Cl-1 is chloride ion, O-2 oxide ion, P-3 phosphide ion, C-4 carbide ion, S-2 sulfide ion.
So we're just doing what we did on this paper.
Basically, that's what we're gonna be doing here, but let me help you out with a couple of these first. That one good? Okay, so what you're gonna do first is, like in the very first box up here, you're gonna be combining those two ions together. So like in the very first one, you have Na positive 1 and Cl negative 1. Which one do you write down first?
Positive.
Positives always come first.
Is that all we need in the box?
Hmm?
Is that all we're writing in the box?
So, yeah, and so box number 1 here, you're gonna have Na positive 1, Cl negative 1. Then you need to balance it out. What do you have to do?
Nothing.
Nothing, it's already balanced out. Now make sure you have the positive first, negative last. Then, if you look down towards the bottom, you'll see also like a Roman or a number 1 down here at the bottom. That section is for the name.
Sodium chloride.
So, right, make sure you get rid of the word ions from both names. So you name the positive ion, sodium. You name the negative ion, chloride. So NaCl is called sodium chloride.
Wait, so if we're balancing it out, do we just have to put the
Okay.
subscript?
So let's try the next one here. The box right beside it, where the two ions you're combining together.
Magnesium ion and chloride.
Mm-hmm. So write down Mg positive 2, Cl negative 1. All right, now, the charges don't balance out. What do you have to do?
Balancing
Okay, what do we need?
Another chlorine.
Another chlorine. So another Cl negative 1.
So is that all we want to do?
So then, Mg positive 2, Cl negative 1. What do I write after magnesium?
Nothing.
Nothing. What do I put after chlorine?
2.
2. So put subscript 2 down here. That's it. So then when you get this part, if you're showing this up here, circle or box in this part right here.
Do we have to show?
If you can figure it out without doing this, that's fine,
Alright.
okay? I'm just showing this, just to try and make it a little bit more visual. But then, for number 2 down below, you need a positive ion first, magnesium. And then a negative ion last, chloride. So magnesium chloride. Okay, let me skip over one. Let's go to number 4. All right, so for number 4, what are the two ions you're combining together?
10 chloride.
Okay, so you write down 10 first, so Sn positive 4, and then Cl negative 1. Now, if you check out the charges, they don't balance.
What's needed?
We need 3 more chlorides.
Okay. So therefore, you have SN positive 4, Cl negative 1. What did I put after 10?
Nothing.
Nothing. What did I put after chlorine?
3.
Not 3. 4. Okay. And the thing is, it's also a good thing to check that when you're doing this is to check your charges. So for example, even though you don't put a 1 down here, it's assumed to have a 1 after the 10. 1 times positive 4 gives me a positive 4 charge. 4 times negative 1 gives me a negative 4 charge. A positive 4, negative 4, the whole thing goes 0. If you put a 3 down there, that means you only had 3 chlorines. Now, this one has 2 names to it though. When you're writing this one out, I want you to write out both names completely. Don't try to shortcut it. So what's one name for this?
And
10,
chloride.
10-4 chloride. Yeah, Roman numeral 4 in parentheses. Chloride. And what's the second name for it?
It's
Damn it. Chloride.
Mm-hmm. It also goes by the name of stannic chloride. Okay. Whatever you do, do not try to do a shortcut and go 10-4 / stannic chloride. Write both names out completely. Everyone understand that? Okay. So I'll be around to help. Tomorrow, hopefully tomorrow, we'll be getting into polyatomic ions. And start doing this with polyatomic ions. It's almost the same thing, but there's a few differences between them. Yeah.